Hi, I'm Andy, and this is my lesson on the wrapper classes in Java. In this lesson, I'll introduce you to the wrapper classes by discussing why they're useful and how to use them. I'll then discuss how the Java compiler makes using these classes easier through processes known as autoboxing and unboxing. Let's get started. One limitation of array lists, as opposed to arrays, is that array lists can only contain object references. You can't put primitives into array lists. That means this line of code is perfectly valid, but this one is not. This is a big limitation since programs often have to deal with collections of numbers, and it would be nice to store those numbers in array lists. Fortunately, Java has a solution to this problem called wrapper classes. Wrapper classes allow us to store primitive values as objects. Here's what I mean. Let's store the number 7 in a primitive int variable called primint. Now let's store that same number in an object. We can do that by making an instance of the integer class, like this. Here's a picture showing how both the primitive and object are stored in memory. Notice that the integer object serves as a box or wrapper around the primitive value. That's why we call the integer class a wrapper class. But why would we want to do this? Well, remember, there are times when we simply can't use primitives. We have to use objects, such as when we're storing numbers in array lists. Let's see how that works. We'll first make 3 integer objects. Then we'll make an array list of integer objects and add those 3 integers to it. So that's how you can add numbers to an array list. You simply have to wrap them in the appropriate wrapper class first. Without wrapper classes, there'd simply be no way of adding numbers to array lists. Now let's look at the integer class a bit more carefully. It's a simple class with just a few constants and methods you should be aware of. First, you'll notice 2 static constants right here, which contain the biggest and smallest int values you can use in your programs. The integer class contains lots of methods, most of which you'll never need to use, but a few are pretty useful. For example, this int value method here returns a primitive int containing the value of the integer object. And there's also a static method here called parseInt, which I've used in many of my previous lessons. It's passed a string containing digits and returns the primitive int containing those digits. Lastly, notice that the integer class, along with all the other wrapper classes, is part of the java.lang package. That's the package automatically loaded by the Java compiler, so we do not need to import the wrapper classes when using them in our programs. So that's basically it for the integer class. As you can imagine, the wrapper class for doubles, which is called double with a capital D, is very similar to this integer class. Okay, back to our program. I need to show you one more thing here. Let's try to add primint to the array list. We'll also try to add a primitive literal, just the number 82, to the array list. Then we'll print the contents of the array list. Obviously, neither of these lines of code should work. As mentioned earlier, you cannot add primitives to an array list. We can only add integer objects to this array list. Let's see what happened. So this is surprising. Not only did neither line of code report a compilation error or runtime exception, but both numbers seem to be successfully placed into the array list. What happened here is a process called autoboxing. When the compiler processed these two lines of code, it took those primitives and boxed them up into new integer objects. Then those integer objects were added to the array list. In other words, when an integer object is needed for an operation, but only a primitive int is passed, the compiler will automatically box that int up into an integer object. That's why we call it autoboxing. Here's another example. Let's see if this line of code, which assigns an integer object reference to a primitive int, works. It does work. Again, that's because this int was autoboxed into a new integer object before the assignment operation took place. Now let's see if the opposite works. What happens when we pass an integer object when a primitive int is expected? For example, let's assign the integer at index 1 of our array list to a primitive int and see what happens. So it worked. You can pass an integer object when a primitive int is expected. That's because the compiler does a process called unboxing in those situations. Unboxing is the exact opposite of autoboxing. The compiler takes an integer object and unwraps it to obtain the number that's inside. Here's another example of unboxing. The math class contains a static square root method that needs to be passed a primitive double. Let's try to pass a double object instead. This worked because the compiler unboxed the double object into a primitive double when it was passed to the square root method. And that wraps up this lesson on the wrapper classes in Java. I'm Andy. Thanks for watching and coding with me today.